Now, Year 12, I'm going to go through example number 5 for resisted motion. So the example is here. It's also in your textbook. A body is projected up from the Earth's surface at a velocity of u. Acceleration of the particle is given as a equals k on top of x squared. So we're talking about displacement here. And it's going towards the centre of the Earth, which is obvious because it's coming back down. Prove that v squared equals u squared minus 2gr squared outside of 1 on r minus 1 on x, where the radius r is the radius of the Earth. If u squared equals 2gr, show that the body will reach a distance of 8r from the Earth's surface in 2.72 hours. Also find the escape velocity. So there's a lot going on here, but this is a much better example because it has numbers. So let's get some things started. So here's the Earth, and what we're going to do is we're going to say, all right, the centre of the Earth is here. We're throwing this thing upwards. It reaches a point there in 2.72 hours. Now, that distance is 8r. But we've also got to take into account the radius of the Earth, 8r, because the object is thrown from the Earth's surface. Coming down, the resistance back towards the Earth is minus k on x squared. Now, that's our situation. That's what we've got. We're throwing something up from the Earth. It's going to reach a long way up because 8 times the radius of the Earth is a long way. So we've projected it up there and we have to resolve these forces. So let's have a think about this. First of all, let's write MA is going to be the result of our forces equals minus k x to the minus 2. But the problem is here, I'm going to end up with that m. Now remember, m is just a constant. So I'm going to make that part of the constant with k. All right? I'm just going to incorporate it there. So now what will happen? A equals minus k on x squared. So, at the time when we throw it, when x equals r, because we're going to be talking about this from the centre of the Earth, when x equals r, gravity equals minus k on x squared, which is going to be minus k. Now, x is our displacement, and that's r squared. And that's what g is. I'm going to multiply that minus that r squared over and take the negative over. So I'm going to get negative r squared g, and that equals my constant k. Now, we're at this situation where we have to make a decision about what we're going to use. Remember, we got all those options, but what we're going to use, or what we need to use, we have to think, are we going to use dvdt? Are we going to use v dvdx? Or, and in this is a case, we're going to use the half dv squared dx. And that is going to equal our acceleration. So let's get back here. Our acceleration, d half dv squared dx equals minus k on x squared. That's from our equation here. But we know what k is. We now have a value for k. So d half dv squared dx equals minus r squared g, the radius is a constant, gravity is a constant, over x squared. Now, let's integrate both sides. So we're going to integrate with respect to x, or integrate both sides. This one's pretty easy. I'll just get a half v squared. And here, you've got to remember that this is minus r squared g x to the minus 2. So when I integrate that, I add 1 to it. Remember, my minus r squared g is a constant. When I integrate it, I'm going to add 1 to the power, so it's going to be x to the minus 1. I divide by that, so divide by -1, and I'm going to have this constant. So half v squared will equal, the negatives will cancel, r squared g x to the minus 1 plus c1. Now, when x equals r, v equals my initial velocity. So a half u squared equals r squared g, 1 on r, because that's what x to the minus 1 is, plus c. That r and that r will cancel. So I get a half u squared equals rg plus c. So then a half u squared equals minus rg equals c. So my equation is now a half v squared equals r squared g x to the minus 1 plus a half u, the initial velocity, squared minus rg. Okay. Let's just rewrite that a little bit. Half v squared equals a half u squared minus rg plus r squared g on x. I've just rearranged that a little bit. Now, multiply by 2, v squared equals u squared minus 2rg plus 2r squared g on x. And if I wanted to go the last bit, v squared equals u squared minus 2rg and I'll be left with, and I'll put a squared in there, I'll get 1 on r minus g, 1 on x. All right, so I took an r squared g, I got 1 on r, that'll just equal that. I've got my minus there, and that is what I needed to prove. Okay, let's go back and let's just take this statement. Now, if u squared equals 2gr, this is the second part of this thing. Look over here. If u squared equals 2gr, here it is. If u squared equals 2gr, let's see what we get. So, v squared equals u squared minus, sorry, it's not the u squared. I'm going to put in 2gr minus 2gr, and note, I'm using this one up here, plus 2r squared g on x. And wow, look at that. That goes and that goes. So v squared equals 2r squared g on x. So therefore, v equals plus or minus, we'll take the r out, but the rest of it is going to be the square root of 2g on x. But we know that v is positive, it's going up. So, hence we get v equals r square root 2g on x. So we've got velocity in terms of displacement. Tidy that up a bit. V in index form, r root 2g x to the negative a half. All right. V is dx dt. R 2g x to the negative a half. What will we do? We'll take that x over the other side. So remember that's 1 over root. So that'll become x to the half dx. And over here, I'm going to get r constant, root 2g constant dt. And now I'm going to integrate. I'm going to add 1 to the power, 3 on 2. So x to the 3 on 2. And divide by that. So that's going to be 2 on 3. I'm going to leave my constant on the right here. That's just one big constant, r root 2g. I'm going to get a t, and I'm going to get a constant here. I'm up to c2. Now, but when t equals 0, we're at the centre of the Earth. So x equals r. So I'm going to get 2r to the 3 on 2 on 3 equals, t equals 0, that goes c2. So my equation, 2/3 x to the 3 on 2 equals r root 2g t plus 2r to the 3 on 2 over 3. Now, what are we trying to find? We're trying to find that it'll reach a distance of 8r. So the total distance we want to find, we're trying to show this is going to equal 2.72. So we want to find t when x is 8r from the centre of the Earth. But let's look back. If it's 8r from the centre of the Earth, the total distance, if we're talking from the centre of the Earth, is 9r. Oops, better make that a capital. 9r. So we go down here. We want to find t when x is 9r. What is x? When x equals 9r, what is t? So 2/3 9r to the 3 on 2 equals r root 2gt plus 2r to the 2/3 on 3. Now, 2/3, that's going to be 9 square root is 3 cubed, 27. The square root of r cubed equals root 2g rt plus 2/3 the square root of r cubed. Let's take that 2/3 r cubed over the other side. So I get 2/3, 27 root r cubed minus 2/3 root r cubed equals root 2g rt. Well, that's okay. That just gives me 26. I've got 2/3 27 and 2/3 1. So I'm going to get 2/3 26 root r cubed equals root 2g rt. So let's write this a bit. 2/3 26. Let's take the r squared out of there, which will be r, and we've got root r equals root 2g r times t. Hey, divide by r, that gets rid of that. So we're nearly there. And we get, and we'll multiply the 26 on 2. So we get 52 on 3 root r equals root 2gt. Now, we know, it tells us in the question that r equals 6,400 kilometres. But we're doing metres per second. So that equals 6.4 times 10 to the power of 6 metres, because gravity is 10 metres per second. So we've got to have everything in the same. So let's go back. (52) on 3 root r equals root 2gt. Let's take that root 52 on 3 root the radius on root 2g. That's going to be my t. 52 on 3 square root the whole lot r on 2g equals t. Let's now put in these values, these two here, this one and this one, and I'll get 52 on 3, the square root, 6.4 times 10 to the power of 6 over 2 times 10. We don't need to be worried about the negative, equals t, which is 9805.21. We divide by 60, 5.21, because it's in seconds. We'll divide by 60, and we'll divide by 60 again. That's t. And when we do that, we get 2.72367 hours. 2.72 hours equals t. Whew. Righto. Let's do the last bit. To escape Earth, escape velocity. If v squared equals u squared minus 2g r squared 1 on r minus 1 on x. To escape Earth, to escape x approaches infinity, therefore 1 on x will approach 0. Hence, v squared equals u squared minus 2g r squared 1 on r minus 0, which equals u squared minus 2g, 1r will cancel, so I've got r. To never return, to get out, v squared has got to be greater than 0. If it stops, it turns around. So u squared minus 2gr, therefore 2gr, is u squared. Now, we know g, 2 times 10. We know r, 6.4 times 10 to the power of 6. So u squared has got to be greater than that to get out, which is 128 times 10 to the power of 6. If I square root that, and I'm only taking the positive, u's got to be greater than that. That is 11313.7085 meters per second, which is 11.3137085 kilometers per second. That's what the velocity's got to be if you want to get off the Earth, or 40,729 kilometers per hour. So to escape Earth's gravity, you've got to be going 11.313 kilometers per second, or 40,729 kilometers per hour. All right, HC awaits you. Good luck.